Thank you. Good afternoon to everybody. I'm Esther Hurtós. For those of you that do not know me yet, I'm responsible for research and innovation policy and public programs in EURECAT, which is a technology center, an RTO, the second largest one in Spain. Okay. And I'm also part of the policy focus area at the EMMC. I'm co-chair of teaming up with Nadia and Donna. So I'm going to present a benchmark of the potential research and innovation programs that can be of interest for the EMMC roadmap priorities. And the aim of the talk is to provide an overview of the research and innovation funding programs within the next multi-annual financial framework for this new 7 years period, and to make a first assessment of the main possibilities to implement the EMMC roadmap through this program. And the topics to be addressed are I will start with a reminder of the EMMC roadmap priority topics and recommendations that come out from it. Then I will provide an overview of these relevant research and innovation programs. And I will stop a bit more on Horizon Europe, and I will finish by closing the two fields and providing an overview of which are the programs in which there can be more opportunities for the EMMC community. So, the EMMC roadmap in a nutshell, the priority topics and recommended actions, most of you are very familiar with it, but just in case someone has joined for this session, the recommended actions in the recently reviewed roadmap are regarding model development and validation to improve accuracy and reliability and validation, on interoperability, the ontology governance and support of tools and standards, on data repositories and marketplaces, the digital hubs network and providing seamless services for industry, on translation and training, the translation for SMEs and training in the diverse aspects of materials modeling and digitalisation, regarding industrial software deployment, supporting the European software industry and its underlying base, and regarding industrial integration to support the acceleration of maturity growth in industry. So, the multi-annual financial framework, once every 7 years, the European Union outlines its future long-term budget, which is called the MFF. And we are now starting a 7 years period up to 2027. And one of the purposes today is to show that there are other opportunities apart from Horizon Europe. That is, of course, the main one. So in this table, there are many other headings in this, because this is the budget of the European Union for the future period up to 2027. There are many different headings. I have highlighted those in which there are programs which have some research and innovation content related to materials research, and therefore where materials modeling can have a role. And these ones are 3: Horizon Europe, Digital Europe, and the European Defence Fund. And I would also like to highlight that in terms of budget, the biggest one is Horizon Europe, and Digital Europe and the European Defence Fund are smaller in terms of budget, but still they have more than 1,000 billion per year available. So they are significant. And making a zoom and defining better these 3 programs, Horizon Europe is the evolution of Horizon 2020, and it's the program, the research and innovation program for Europe for the next 7 years, and aiming for a green, healthy, digital, and inclusive Europe. And it's important to highlight that more than 1/3 of the budget, over 35% of Horizon Europe spending, will contribute to the climate objectives. Then there are two other programs which are new. There is Digital Europe. Digital Europe is not about research, but it is a lot of about digitally enabled innovation, as Matteo Mascagni will tell us later on. And the focus of this program is on building the strategic digital capacities of the European Union and facilitating the wide deployment of digital technologies to be used by citizens and businesses. The other one, which is new on the stage, is the European Defence Fund, that will be also further explained by Erno Vandeweert later in this session. And it is the European program on research and innovation on defense, in defense. It is very much capability oriented. And what is relevant for us today is that there is, it addresses also materials and components and its applications in the defense field. So now let me stop a bit more on Horizon Europe, which is the main program. And also because the other programs will be better addressed during this session. And in Horizon Europe, there is the a three-pillar structure that has already been shown by Javier Sanfélix in the plenary this morning. The pillar 1 on excellence science, the pillar 2 on global challenges and industrial competitiveness, and the pillar 3, which is the pillar of innovation. Our main focus is in pillar 2, which contains the combination of the programs we already know, but now they have been reorganized and merged into what is called as clusters. So clusters in the context of the Horizon Europe means programs within this pillar 2. And in particular, the most relevant are these two highlighted ones. The cluster 4, the related to digital industry and space, for which we have already heard a very good introduction this morning by Javier Sanfélix, and also cluster 5 on climate, energy, and mobility. And why are those interesting? In cluster 4, the main areas of intervention are advanced materials and manufacturing, key digital technologies, artificial intelligence, advanced computing and big data, and circular, low carbon and clean industries. Whereas for cluster 5, which is the cluster for climate, energy and mobility, there are topics to fund research on energy supply and storage, which means batteries and so on, buildings and industrial facilities in energy transition, which means materials for construction and so on, and transport and mobility, which also means materials for automotive, railway, whatever. And it is also important to mention that these two clusters are the biggest ones in terms of budget within pillar 2 of Horizon Europe. And besides the clusters of Horizon Europe, also very closely related to the pillar 2, that is industrial competitiveness, there are being prepared 5 missions, which is also a novelty of Horizon Europe, and for which the detailed deployment is not defined yet, and it's expected by the half of by mid 2021, and also 49 partnerships. which are somehow the evolution of the what we already know as public-private partnerships, EURECAT, and so on. These partnerships, in an effort to simplify and reorganize things, have been defined as 3 different types of partnership. And I just mention here the institutionalized partnerships because the other 2 types, which are the co-programmed and the co-funded, their calls will be published within the standard work programs for the Horizon Europe. So somehow it's not easy to miss them. They will be together with the topics not coming from partnerships. So regarding the institutionalized partnerships, that may have some materials research and then modeling interest are the Circular Bio-Based Europe, which is the follow-up of the BBI partnership that you may already know, the Clean Hydrogen, the Clean... this is the overview of and a zoom of what's in Horizon Europe, with a focus in cluster 4 as the main one, but also in cluster 5, where materials are more addressing circularity and climate and energy impacts. And then the partnerships, in which there are a few ones which will be run independently from the standard programs, and that might have some interest in applying materials modeling for certain fields of application. So now, going back to the EMMC roadmap implementation, what we can see is that regarding model development and validation, the main programs of interest are Horizon Europe Cluster 4 and possibly also Cluster 5. Regarding interoperability and integration, the key one is Horizon Europe Cluster 4, but there might be opportunities also in Digital Europe program. And regarding data repositories and marketplaces, we will see later on, but also Digital Europe and again Horizon Europe Cluster 4. For industrial software deployment, the recommendation is monitoring what's in Horizon Europe Cluster 4, the digital part, not the industrial, not so much. And regarding these 2 priorities, the translation and training, and also the industrial integration and economic impact, opportunities are in fact in all the potential programs in Horizon Europe Cluster 4 and Cluster 5, in the Horizon Europe partnerships, and then for defense applications in the European Defense Fund. And in the Digital Europe, it's important to highlight that there is a block dedicated to digital skills. So that might be the interest. And in concluding, on the opportunities for funding the EMMC roadmap priorities, as a first conclusion, we can say that there are many different possibilities, more spread into different programs than before. And we can celebrate that materials digitization is now well embedded in the scenario, which was not so obvious at the beginning of Horizon 2020. So this is, in my view, a success of the Materials Modeling Council. There is also a greater dispersion in the possibilities for translation to SMEs and industrial integration. This dispersion has always been, but I think that now even more due to the largest programs diversity. So I would say there is probably more opportunities for many different kinds of business sectors. I would also recommend to follow the new programs. Horizon Europe, somehow it's a continuity, and we are all familiar with more or less familiar with this program, but it's important that we learn more about the Digital Europe and European Defence Fund, and this is also the point of this session today. And also to follow the institutionalized partnerships for specific fields of application. And with this, I conclude this introductory talk for the session.
Welcome everyone to this session on the policy of within the EMMC International Workshop. I am Javier Sanfélix, and together with my colleague Yanaris Ortega, we will present the understanding that we have on pairing materials modeling and characterization under the framework of Horizon Europe. We both are project and policy officers in the unit of Materials for Tomorrow, Directorate General for Research and Innovation. Next, please. So this presentation is structured in 5 sections. We will hear a little bit on the structure of Horizon Europe, but I will do it very quick because Esther already presented it before me, and I also did a bit this morning. Then we will talk about what has been done under Horizon 2020 for materials modeling and materials characterization. And then we will analyze why coupling these 2 areas makes sense for us and how the Horizon Europe. Next, please. So here I just gonna mention that we, as I said this morning and Esther presented, digital industry and space is cluster 4 of is where we in our unit are putting the input in topics for Horizon Europe and where we are describing the work for the materials modeling. Next, please. This slide was presented this morning as well, but it is important because these are the aspects that we have taken into account when drafting the Horizon Europe Work Programme for 2021-2022, and is that it is aligned with the key policy priorities of the European Commission, and a very important one for our area is the twin green and digital transition. The objective is climate neutral, circular and clean industry, and also support the digital transformation of the industry. I presented it this morning, so I think we can go to the next one, please, Yanaris. So what these policies create new challenges for the European industry. One of them is that there is the need to design new sustainable materials and processes, not only create new ones, but also improve those that are already in the market and that we are already using. And for that, we need to develop innovative tools that support industry in anticipating the issues at the early stages of the development process of these materials. Industry also needs to bring us these materials into use in the market as soon as possible, because we cannot wait much. We know the climate crisis that we are having. So supporting industry with tools that accelerate the time to market, reducing it and make it cost effective, and overall assuring an effective quality control of these materials. And this was an animated slide. Now it should appear that we think that advances in characterization methods and computational modeling are key to address these challenges that industry is going to have because of these new priorities that we are identifying. And next slide, please. And what has been done so far under Horizon 2020 materials modeling, I described it a little bit this morning as well, but I will give I'll go quickly through it in case not everybody was present. Materials Modeling and Horizon Europe at Horizon 2020, sorry, is very much looking into the transition to digital and data-driven solutions for companies, okay? With the objective to make industry more competitive by applying materials modeling, always looking at trying to increase the usage of the materials modeling by the industry in the material design, in the material processing, and the manufacturing. We had topics specific for to translate this the current manufacturing challenges that the industry has into material modeling workflows, in order to facilitate the uptake of simulation by industry. And also, there were calls to develop multi-criteria decision tools and applications to support decision makers and facilitate their based on simulation and modeling. A very important aspect that it was mentioned this morning also is that we looked at a long-term reusability of the data and the models that are developed, and for that there were projects to develop marketplaces having in mind fair data principles, which is findable, accessible, interoperable, and reusable data. And a very important aspect of the ACE 2020 projects and material modeling is the development of ontologies to increase the operability, the European material modeling ontology, which continues growing, and there is a big interest on that. And now I will give the floor to my colleague Yanaris, and she will continue with characterization.
Thanks, Javier. So maybe I should put my camera on, no? Yeah. Hi, everyone. Thanks for inviting us here. I'm Yanaris Ortega, and I will be presenting mostly the characterization part. So here I'm going to present what we have done, the characterization side in Horizon 2020. So basically, characterization is a broad of a set of processes by which materials, structure, and properties are proved and measured. So that's why it's a major importance, and is the fact that most of the NMVP projects, so NMVP is our program, they contain these activities, either advanced or not. So it's a fundamental key enabling process that is fully integrated, and that's why we have to make the point that it's really necessary to make the link with the modeling activities. So what we have done is in Horizon 2020, we have a portfolio of projects mainly focused on the development and improvement of characterization techniques. Very much a focus on on making the link between modeling, the experimental work, but focusing in the real user cases in the manufacturing sector. This project also have created open innovation environments with the aim of sharing data, knowledge, and make this set of results publicly available for the concerned community. An important thing that we have done, or we have started in Horizon 2020, it was the creation of the documentation structure for characterization data, similar to the one created for the modeling MODA. But in this case, it's of course for the characterization data and metadata associated to any characterization experiment. And this, it has gone a bit further with the pre-standardization process for these workflows, with the objective of making the definitive reference workflow when describing and documenting material characterization data and experiment. So the ultimate goal of this is to have an official pre-normative document, and of course to be used characterization community beyond the EU-funded projects. So the other important aspect is and here there is a key player that we need to mention, and is the European Material Characterization Council. So it's the sister of the European Material Model Council, and they currently they are gathering the inputs from the industry and also the academia community in order to draft the roadmap and to have the most important scientific guidance and gaps, as well as the needs and challenges that the industry might have with respect to characterization activities. So all this with the objective of a strength, the collaboration between academia and industry, which is also that we have been doing since the very beginning with the first generation of characterization projects, but also with the Open Innovation Testbeds projects. And also, as we said before, trying to put together the modeling tools, including ontology. And the link also with the industry common and the first principles. So we know why modeling is important, we know why characterization is important, but we need to, and that's one of the things that we want to emphasize here, and that would be one of the reasons why this coupling will be supported during Horizon Europe, is because we understand that by doing this coupling, we could have a very much understanding on the phenomena and the complex functional materials and systems. By using this coupling, we will be able to have a better design of new materials and systems with even tailor-made characteristics that, for instance, then the industry or the manufacturing will need to have less experimental time and experimental testing, which can be translated in a reduction of production costs, usage of materials, and of course, time to market. Of course, is for the case of manufacturing, that will be also translated into prediction of performance and prevention of production losses. So it's a straightforward also the support to the digitalization of industry, and mainly in manufacturing technologies. And this making this coupling also will be an space for supporting an open innovation environment for sharing infrastructures, knowledge, data, and fully supporting, of course, the interoperability, which is one of the most important objectives that we have with this coupling. So, as I said, indeed, the materials modeling and characterization together will be supported in Horizon Europe. What we expect in the first 2 years, so first of all, is that these both communities, characterization and modeling, mainly the two councils, sit together and discuss about what is important in terms of how we can reach this full interoperability between materials modeling characterization in terms of data and workflows. Here I'm speaking about the CHADA for characterization, the model for modeling, and EMO for ontologies. We expect also that the proposal could come up with open repository for a knowledge transfer, that they also could develop new generation or to improve the already existing characterization and modeling techniques, which could support the European technology area. But here we want to stress the importance of the low carbon and clean industry applications in order to align what we expect here with the principal policy strategies like the Green Deal. And of course, it has to be, we have to find a way of translating the industry needs and challenges into innovation solutions in a proper way. So that's more or less what I have. So what are the recommendations that we have? So summarizing, this is what we expect to happen in the first 2 years of Horizon Europe. Then there are many things that we are missing. First is to establish a more systematic dialogue between the modeling and characterization areas, mainly the two councils that we already know, and to sit together and to define which are the actions that we need to take in order to make this full interoperability happen, but also to identify the industry needs and challenges and how we could, as a combining both areas, how we could contribute to this more concrete terms. And the recommendation is that maybe it could be really useful to reach out to other funding scheme other than the Commission, the European Commission, as we have seen that only the European Commission has been invited, but also to bear in mind that there are national and regional funding schemes that could contribute as well to develop all these actions that we need to put in place in the coming months and years. And thanks a lot. That's everything from my side. I don't know, Javier, do you think I covered everything? Or
you did very well, Yanaris. Thank you.
Okay. Erno Vandeweert, working for a new Director General, which was now a little bit more than 1 year installed in the European Commission, that's dealing with defense industry and space. And basically, we are managing the new kid on the block, the European Defence Fund, which is a new spending program focused on the European defence industry, running from 1st of January this year to the end of the next, this long-term EU budget. I was asked to have questions for a yes/no poll. I don't know whether that's still on, but one of the things which are interesting for us to know is that whether you have been involved in research and development activities in the defense sector as a researcher or as a research institute or university or a company. So if the yes/no poll is on, happy to see your input there. Let me summarize the European Defence Fund in one slide. It's an industrial program, so it's a funding program that wants to foster the competitiveness and the innovation of the European defence industry. And it's also driving for a deeper cooperation in a domain which is traditionally very national managed. So we are looking to fostering cooperation between the governmental actors, so the ministries of defense, but then also to the industrial stakeholders, the universities and the research organizations. It's a defense-specific program which works outside Horizon Europe, so it has its own regulation, its own budget. And we are not going to promote really dual-use research if that would exist already. But what we are always looking for is to synergies with the Horizon Europe and other civil programs to see whether results generated there can be taken up in a defense context and vice versa. The way how we do this will be through competitive calls for proposals. So we are looking for the best solutions for our challenges. And we do this by funding research and development projects through grants.
So there is the answer to the poll. Just to mention that it's 58% yes and 42% no.
That's really, really amazing. Thank you very much for this, Gerard. Thank you. So then probably the rationale for a European Defence Fund is not so illogical for you to understand. So we have across Europe a lot of inefficiencies and also because of fragmentation in the current markets. And we think that by driving towards more synergies and economies of scale, we could lift this, and then also protecting the basic interest of the union and the member states, and also the citizens. And then this comes then to a third strategic driver, which is trying to be more autonomous in the European Union and less depending on the other parts of the world. That's a case of how fragmented we are. It's already now a couple of years old, this slide, but still, if you see that in the Union, we have currently in use more than, close to 180 different large weapon systems, compared to the US, where they use 30 large weapon systems. I think it's a driver to see how we can work better together. And of course, there's a lot of reasons why we have so many different weapon systems in use in Europe, but also with these systems getting gradually older and older and need to be replaced, there's a real strong call for better cooperation. This is in one graphic presentation how we see the European Defence Fund. So it's combining both research and capability-driven development. So when we start from the left side with research, the fund will have, the total fund will be close to 8 billion euro for the whole long-term financial framework, so 2021 to 2027. 2.7 billion will be reserved for funding research projects, and there 100% of the funding will come from the EU budget. When we move, so in the same program from research to development, there we rely on co-financing with the member states. So we put 5.3 billion, which can be used in their capabilities, in their defense systems. And then the third part, but this is outside the financial part of the European Defence Fund, and totally relying on what member states would put into the budget, is to acquire these weapon systems, which would be developed through this research and development cycle. So there, as said, we cannot fund from the European Union directly, but we can help with a number of measures in the financial toolbox. This is probably clear for all of you who are into Horizon 2020, Horizon Europe, or earlier programs. But just to let you know, we're following a little bit the same approach. We will draft and publish work programs on an annual basis. On these content of these work programs, we will launch calls for proposals where there are mostly competitive calls for proposals. In some cases where there's almost no other technological solution available, we could go for awarding grants to identified beneficiaries, but most of the calls will be competitive. Then we will evaluate the submitted proposals with the help of technical experts. We will set a ranking list and then award grants to the best proposals per call or category of actions. So what will be in these work programs? This is, of course, a little bit more sensitive than you would find traditionally in a civil research program like Horizon Europe. So we will look very carefully on what are the needs and the priorities of the member states. What do they need in their armed forces on the medium and longer term? And we work very closely with them to define these work programs in the program committee. Member states have a quite a strong voice in saying, okay, this is to our likes, this work program, but also in looking into the ranked list of proposals which come out of the evaluation of the applications which we receive. For your timing, what we now working very, very hard on is to publish our first work program before summer 2021. So that's tomorrow, so to speak. And this would go also like where you find the calls for Horizon Europe or Horizon 2020 for the time being on the funding and tender opportunities portal. What kind of projects are we funding? There's basically two types of projects. We have research projects, research actions, as this in the Commission lingo, which are primarily focusing on research, but not blue sky research. We need an exclusive focus on defense applications. That means that we are looking to lower TRLs up to 4 to 5, but not just ERC type of research. Then the more advanced projects will orient on the development phase. That means that we are developing or new defense products or technologies, or we are looking into upgrading existing ones with more advanced technologies. But we are not going into the production of or use of weapons. So we are really still in the R&D phase. All the steps which go behind the testing and even a number of other activities, but really using in production is up to the member states. We have a special type of activity in the sense that we are spending up to 8% of the overall budget of close to 8 billion euro into funding R&D into disruptive technologies for defense. And these are technologies that when they are used, they really can change the things at the level of defense affairs, so the concepts and the conduct. So these are or very advanced technologies or technologies which are used in a certain context, but which tend to be adapted to be used in a defense context and change the way how things are running. A project so an action project can consist of different activities. And for the research part, this is mainly related to activities to generate new knowledge or to integrate parts of new knowledge which is already available and to get it working better together and on more autonomous together. Looking into the feasibility of new concepts. But then you can also look into more development type of activities, so looking to design studies, going all the way up to system prototyping, product testing, qualification, certification, and then also in the context of making things work longer at a better efficiency. We are looking for technologies to reduce the life cycle costs of very expensive military capabilities. Now, focus a little bit on advanced materials. It's generally recognized by the member states already for a very long time that materials and also structures are an important component, and we need to look very carefully in this, also in looking to see how the materials needs are translated and then the materials capacities are translated in current and future capabilities. On the website listed below at the bottom part of the slide of the European Defence Agency, you see a number of relevant material categories which they have already identified. In the European Defence Fund, there will be dedicated funding available for calls in these categories. We're talking about camouflage, we're talking about energetic materials, so explosives, we're talking about new materials, also about replacing materials which are no longer available or obsolete, also in REACH context. Protection, of course, is very important. And then performance and testing of the structure and the materials which are used in very sophisticated systems is very important. And one of the things that also is highlighted there on that page is modeling. So we will also look into that in the context of funding projects in the EDF. The EDF is a little bit more restricted than the civil research programs, in the sense that only legal entities which are established, so as the main rule, only legal entities established in member states or in associated countries, and that's currently the EFTA members, which are also members of the European Economic Area Agreement, so Norway, Liechtenstein and Iceland can participate and get funding, and these should be entities which are established in the EU or in the associated countries, and which are not under control by third countries or by companies established in third countries. That's a very hard rule, and exceptions can apply, and that is also then to be discussed with the member states, that entities can enroll and get also funding from the EDF if there is no risk on security of supply, if the sensitive information, which is very much into these projects, is and continues to be protected, and if the intellectual property remains within the European Union. There is a possibility also to work with companies outside the Union under the same conditions, but such entities, such companies would not receive EU funding. We didn't start from scratch, so since 2015 we are working with some smaller test programs, so to speak, to prepare for the 7.9 billion European Defence Fund. There was one program on research, testing research activities, that's the preparatory action on defence research. And then secondly, the European Defence Industrial Development Programme was testing the capability-driven development of defence systems and technologies. Here I show you, and I'm not going to in any detail, the 18 projects on the two slides which receive funding on the preparatory action on defence research. And for instance, the ACAMS2, which is on adaptive camouflage, the VESLIFE, which is on force protection systems, so ballistic protection, and the TALOS project, which is running on very high power laser effectors. So we're using a lot of materials research on lasing materials, on claddings, on fibers. They are really showing that materials research is an important component for these defense-oriented projects. In 2019, we funded 8 projects in these disruptive technologies area, and there projects like MetaMask on metal surfaces, Spinar, which is on quantum wells, spin device based hardware, as well as Privilege, which is working a lot with artificial intelligence algorithms for encryption purposes. They are really relying on materials research or modeling aspects, which are developed very much in the civil domain. This is just a slide on the development program. That's a little bit maybe less into your community, but there we have in 2019 spent more than 200 million to support 16 projects with a lot of participation of SMEs. Let me give you a couple of examples of projects. It goes into space, it goes into drone in air traffic management, preparing for future naval and ground systems, and also looking into swarming, all where there is quite a lot of room for modeling approaches. A little bit on what would or could motivate you to enter into also stepping into the challenge and the opportunities with military research and development. Clearly, we keep in the Commission a clear separation between the civil research funded by Horizon 2020, Horizon Europe, and the defense R&D programs. But we talk to each other, so we are looking for synergies in all kinds of domains. And indeed, things which are happening in the civil research can be taken up into military application and vice versa. So we have to see how we can promote this as much as possible. We will not fund basic research, but of course, fundamental research like working on algorithms which are needed to reach a military or a solution in a military environment, that can be funded. What we see is that for the time being, the participation from the universities is rather low, but increasing, and that's mainly in these things where we are looking into the more advanced disruptive technologies. So there we see that a little bit more interest comes from universities, and we think that this is going to be continued in the next calls, which we will launch at close to summer of this year. And we clearly want to reach out to such new actors. We want to tap into your R&D excellence in all kinds of domains, and see how much we can absorb in a defense context. But it should be clear that it's basically the national ministries of defense who set out these defense priorities. So it's not so that the R&D community or the industry can say these are the priorities that the armed forces in the member states have to be happy with. And it brings also a lot of opportunities for you to work with defense stakeholders, like military universities, military research institutes. You bring your expertise into a whole new field, but they also have very specific expertise that they can share with you under certain conditions, which could bring new opportunities for you. There is some anxiety in some of the talks I give from the academic world that a lot of the things which we will fund under the European Defence Fund is classified, and that's true. But we have in the regulation, so the rules of the game of the EDF, a clear opening that academic papers should be continued to be published. And in any case, because most of the EDF is implemented through grants, the intellectual property will remain with beneficiaries which are generating it. And that's now my second question, actually, to end my talk, is that after hearing a little bit more on how the EDF is intended to run, would you consider to extend your project portfolio by applying for R&D funding under this new kid on the block? Thank you very much for your attention, and open to any questions you might have.
Good afternoon, everybody. My name is Matteo Mascagni, and I come from DG Connect at the European Commission. And my unit is dealing with HPC and quantum technology. Quantum technologies. HPC is related to high-performance computing that we are going to see in a few slides in detail. So you can move to the second. So, as part of the next long-term EU budget, the Commission has proposed a Digital Europe Everybody?
Yes, it was breaking up, but if you could turn off your video, I think that maybe helps just to talk to the slides.
Can you hear me?
Yes, we hear you. We just recommend to turn off the video as along to have a better bandwidth.
Okay, I turn off the video.
Okay, let's go on like this.
Okay. So, as I said before, as part of the next long-term EU budget, the Commission has proposed a Digital Europe, a program focused on building the strategic digital capacity of the Union and on facilitating the wide deployment of digital technologies. With a planned overall budget of 7.5 billion, it will shape and support the digital transformation of Europe, society and the economy. The program will boost investment in supercomputing, artificial intelligence, cybersecurity, advanced digital skills, and ensuring a wide use of digital technologies across the economy and society. Its goal is to improve Europe's competitiveness in the global digital economy. It will do so by deploying new digital technologies in order to support a digital transformation that will guarantee high quality. Can you hear me?
Yes. Do you hear us?
Okay. Yes, I can. Yes, I can. Because in my system, it is still reconnecting. So I don't know if you can hear me.
Yeah, we see. At the moment, we hear you.
Okay. I apologize.
I'm still at the slide of Digital Europe program.
Yes, it is correct. It is correct. And
okay.
So Digital Europe will complement other EU programs such as Horizon Europe program for research and innovation, as well as CEF, Connecting Europe Facility for Digital Infrastructure. So next slide, please. Okay, let's focus on HPC, the first part of my presentation. Next slide, please. So what is HPC and what it is so important for Europe? HPC, or of a processor, working in parallel, working together, delivering more than 10 million times the computational power of common laptops. Today, we have supercomputers that develop computational power in the range of the petaflops. The petaflops is basically 1 million billion of operations per second. The next computing frontiers are the exascale computing, where we address 1,000 petaflops. This means billions of operations per second, and the quantum computing based on quantum mechanics that I'm going to show you later. HPC is essential for the digital economy and the digital transformation of the society, enabling big data analytics, artificial intelligence, and cloud technologies, a clear impact on daily lives for everyone. Europe needed to develop new technologies in order to be part of this field. Next slide, please.
Yes.
So HPC can be used for modeling and simulation of various chemical reactions that can lead to understand the neurological disorders and develop to cancer and identify candidate drugs for these mutated proteins. Weather prediction and climate modeling are highly dependent on the computing power and the ability to produce, store, and analyze large amounts of simulated data. HPC is one of the key technologies helping to fight the COVID-19. It can help, in fact, to forecast the trajectory of the spread of infection, support decision-making with scenario buildings and simulations. Next slide, please. We also have the Euro HPC joint undertaking with a specific mission. The mission is to establish an integrated world-class supercomputing and data infrastructure and support a highly competitive and innovative HPC and big data ecosystem. So it is going to be operating even in the next framework program, as we'll see in the next slide, please.
Yep.
Next slide,
yes.
Please. Okay, so this is a proposal for the next MFF. Thank you. With 5 pillars of activities, from infrastructure to technologies to leadership in HPC, use and skill, federation and service, and application. Next slide, please.
Okay.
So the expected outcomes for the next MFF is a hyper-connected world-class supercomputing and data infrastructure. It is serving and fostering scientific excellence in Europe, serving scientific, industrial, and public sector applications. Of course, we wanted to also to contribute to the Green Deal objectives, and also strengthening the industrial innovation capabilities. But in order to do this, we need, of course, new HPC technologies feeding a broader ICT market, and also serving strategic European digital initiatives that we are going to address in the next slide. And also we support the skills and educated workforce, of course, in order to serve all the above objectives and outcomes. Next slide, please. So the synergy with other major initiatives is, for example, the common European data space, the artificial intelligence and cybersecurity, the quantum technology flagships that I'm going to cover in the next slides, and also the joint undertaking on key digital technologies, and also the European Open Science Cloud, and the Destination Earth initiative that is addressing digital twins of the Earth. Next slide, please.
Yep.
So let's focus on now quantum technologies. Next slide, please.
Yep.
Next.
I've got quantum technologies at the moment.
Thank you. So starting from the first. Correct. Thank you very much. Starting from the first quantum revolution that allowed to understanding the physical process at the nanoscale level, we are now basically industrial and societal challenges. And these centers of excellence are user-focused, so they are focused on the needs of the people, of the scientists or whatever in industry. And the center of excellence may be thematic, so they can address a specific application domain such as medicine, life science, or energy. So the question from Adam is right. Normally, HPC is not a general purpose. And in this case, we have a center of excellence addressing a specific domain, but it could be also transversal or on computational science. For instance, we could address algorithms or analytics, data analytics or numerical methods as well. Or in a last kind of center of excellence that we can have, it could be challenge-driven. It means that we can address societal and industrial challenges, for instance, climate change, clean transport, or also we can have the combination of the three kind of center of excellence. So it could be thematic and transversal as well, and so on. And in this way, we can assess specific particular digital related problems by using these instruments, the Center of Excellence, and by using, of course, HPC. So I guess that more or less I replied to the question. Hello, can you hear me?
Yes, thank you very much. Yep, can hear you.
Can you hear me? No?
Yes, we can hear you.
Yes.
Thank you very much for wrapping that up. Yeah, there are some more questions, but I guess, you know, in the interest of time, we should really refer these to the lounge area where maybe you can be joined. So was there any final point? Was there any point you wanted to make, or, you know, just to give us maybe one pointer on the quantum computing side? Matteo?
Yes, can you hear me?
Yes, you're muted.
Okay. So, as I was saying before, there are several application areas in the quantum technology: communication, computing, simulation, sensing, and metrology. So, in each area, I have several slides about each area. And these key areas and activities are part of the Quantum Flagship, and it is a flagship supported by Horizon 2020, and most probably is going to be supported even in the next framework program, Horizon Europe, in synergy with the other programs that I showed you before. So I guess that by using both quantum technologies and HPC, even in hybrid way, we can address and tackle problems that were not addressable so far.
So good afternoon, and actually, thank you for the invite for giving this presentation. In the next 10-15 minutes, I will present you some insights regarding challenges in the supply chains of clean energy technologies, and I will actually try to highlight the potential role of material modeling and digitalization in this field. My name is Alessandro Cavalli, as you know, and as you can see. I'm a project officer at the European Commission Joint Research Center. I will start the presentation briefly talking about the European Green Deal, and I will then present our work on clean energy technology supply chains and the demand for site for these technologies. Before actually starting with the real content, let me shortly introduce JRC, that is the European Commission Joint Research Center. The role of JRC is that of creating a bridge between science and policy. We cover different activities that are strategy and coordination, knowledge production, knowledge management, and we also provide support to other Directorate General. And let's now start talking about the EU Green Deal. So the Green Deal is the Commission growth strategy, and it is focusing on people, planet, and the European economy. Besides reaching climate neutrality by 2050, that is something we've heard a lot, the Green Deal is also about protecting animals, plants, and human lives, and focuses on assuring a just and inclusive transition. Moreover, this transition should help European companies to become, or actually to remain, world leaders in clean products and technologies. Since, as I mentioned, the focus of my presentation is on the energy sector, let's first of all have a look at the current European Union energy situation. So if we look at the situation today in 2020, actually these values are from 2018, should be updated. If we look at the share of the final energy consumption that we get from renewable sources, we see that we are more or less around 20%, which is actually in line with the targets that we had for 2020. So actually, clean energy technologies are already there, and it's something that we know, we can see. I mean, we have all seen PV panels or wind turbines somewhere around ourselves. But it's also true that if we want to reach actually the 2050 objectives, we have to increase the amount of renewable energy technologies installed. And this requires resources that are not only economic resources, but they are also resources in terms of materials and components. So when we, for instance, say that by 2050 we want to have, or we might have 800 gigawatt of onshore wind capacity installed in the EU, and this actually translates in a certain number of turbines that will be installed. And this means that we need a certain number of components to be manufactured, for instance, blades or generators. And this means we need a certain amount of processed materials that have to be produced. For instance, I don't know, the neodymium boron iron powder that is used for making the permanent magnets of the generators. And we need, of course, also raw materials to be mined and refined. We are very well aware of the challenges that accompany the energy transition, and this is why we study low carbon energy technologies, supply chains today, and also how they will evolve in time, and we try to look at the future demand for these materials and components. When we analyze the supply chains of these technologies, we try to answer a series of questions. For instance, which are the energy technologies that will have a role in the European energy mix? What are the components, the process and the raw materials used, of course, along the supply chain? And then we try to assess if the European Union is exposed to vulnerability. For instance, we try to understand if the EU has access to all the resources needed for this transition. We try to understand how much we depend on third countries. And then we also try to see how we can overcome any bottlenecks in the supply chain, and also how we can support the European industry to actually remain or become world leaders in this sector. I want to show you one of our latest studies. Here we looked at the supply chains of 9 technologies in 3 strategic sectors that are renewable energy, electric mobility, defense and aerospace, but here I will present only what concerns the energy sector, so renewable energy generation and energy storage. Now, just for you to understand a bit how we work, when we try to assess the risk in the different stages of the supply chain, we consider several parameters, among them the reliance of EU on other countries, how much the supply is concentrated, and for some stages, like the raw material stage, we also look at the possibility to replace some of these raw materials, and also how much these materials are currently recycled. Now, in this study, we found that almost all the technologies have a high risk in the supply of raw materials, and this is due to the fact that yes, Europe is not very rich in raw materials, And for some of the materials required for the energy technologies, the supply is highly concentrated in very few countries, and quite often these countries have an unstable socio-political situation. Some of the technologies, for instance, batteries and fuel cells, actually presented a very high risk in the supply chain at the assembly stage. And also in this case, this is due to the fact that the production is highly concentrated in a few countries, for instance, in China for what concerns the lithium-ion cells. And here I would like to point out how material modeling can be of help. And of course, it can be of help at the stage of raw materials, so looking at some substitutes materials, but it can also have a role by allowing a faster development and deployment of new products. So actually trying to support the stage of the latest stage in the assembly, in the supply chain, that is the assembly. Another useful insight from this same study is that while some materials are used only in a specific technology, for instance, platinum group metals in fuel cells, other materials are used in multiple technologies. This is the case, for instance, for both light and heavy rare earth elements, borates and cobalt. And this is important because this creates an even higher demand of these materials, and also potentially a competition between different technologies. And in this case, yes, actually, material modeling could help addressing these challenges, accelerating the development of substitute materials so that the demand could be somehow decreased, or at least preventing an increase so hard. I hear a noise, but I don't understand where it is coming from.
It's fine here.
Okay, so you can hear me. Okay, very good. I just hear something, but I don't know where it's coming from, so I will just continue. Now, as I was saying, yes, that the amount of materials is very important, because there might be competition among different technologies, and of course also among different countries, because Europe is not the only one that is actually active in the energy transition. And since the future demand is so important, we also investigated this aspect of the supply chain or of the energy transition. To do this, again, we start with a series of questions, or actually activities. So we try to see in the future which are the energy technologies that will play a role. We try to compare the future demand due to an increase in these technologies and the supply. And again, we try to assess the possible bottlenecks in the future supply, and also we try to see how some technological developments can improve the situation. When we do these exercises, or when we create these scenarios, we use a combination of 4 parameters that are capacity trends, meaning, for instance, how much gigawatt, or actually how many gigawatts of wind or PV will be installed in the future, the lifetime of these technologies, the market share of different sub-technologies, and also the material intensity. So how much of a certain material is required for a specific technology. This that I present here in this picture is the result from another very recent work where we have analyzed the future global demand of rare earth elements due to wind, electric vehicles, and also other sectors. And we saw that while in the low demand scenario, the increase for this material, rare earth element, by 2050 can be less than threefold. In a high demand scenario, that means a different combination of the 4 parameters that you see in the left of the slide, then the increase can even be 20 times the current demand. So, I mean, the situation is not bright, I would say, and also because for this material, the concentration today is mostly coming exclusively from China. So, as I mentioned before, for these scenarios, we use different parameters. And the problem is that often it is not easy to find information on these factors. So we think that digitalization, so having databases that are accessible, where this information for the different materials used today and also developed in the future, this would be very very helpful for us in our work, but of course for the whole community involved with the energy transition and also working with materials. I have one more slide for what concerns the results of a study. So this is more in detail. We looked at the different rare earth elements that are used in these technologies, and the analysis is limited to 2030 because in this case we try to assess not only the future demand but also the future supply, which is actually not that straightforward, but we managed to do it. And we found that for some of the materials, even in the low demand scenario, the future supply cannot meet the future demand. And in this case, again, we see a potential or an instrumental role of material modeling to try to decrease, so working on materials so that the material intensity can be decreased. And in this case, actually the demand will not increase so much as we have observed in our study. Now, this is my last slide, but before I will just recap a bit what I touched upon in the presentation. And of course, reaching a decarbonized Europe by 2050 comes with a series of challenges. We know that, and we are ready actually to tackle them. We need to increase the amount of renewable energy that are installed today, and we have to do it to a large extent. And this requires resources that are economic, materials, and manufacturing, so components and assemblies. We need, therefore, to study the supply chains and the future demands associated with the green transition. And what we have seen so far with this activity is that future demands will be quite challenging, and we need therefore to actually find some solutions. And these solutions, for instance, can be increasing the product's lifetime or decreasing the material intensity. As I mentioned during the presentation, material modeling can be instrumental, so it can support these efforts. And also, as I mentioned during the presentation, digitalization, so having these databases can actually be very useful for all the people involved in this sector. Just for you to know, if you want to keep in touch, here you can see some websites and also how you can find us on social media. And with this, I conclude my presentation and I thank you for the attention.